Hello, everyone. Today is Tuesday, and we are having the protocol sync. We'll be discussing what was happening to the core protocol of the Subspace during last week and in the future. Ivan, maybe you want to start?
Me, right?
Yes, please.
Yeah, sure. Of course, yeah. Last week, after we synced up with the Nazar, I started doing the adding the custom block reward address. So yeah, also it was merged last week. Also, we synced up with the Nazar about the implementation of the partial replica at Friday. Also, we sync up today about how how can I approach it in terms of like processes and how it can be merged. So we came to the conclusion that I can divide the implementation of the partial replica into several steps. One of which will be, for example, fixing the data layout for the replica on the disk. So after that, I can make the replacement of the different pieces of the plot on the disk. So yeah, this is I was up to this during the last week. I'm planning to work on the partial replica this week. So yeah, hope everything will be good with that.
Can you elaborate a little bit on the data layout changes?
Uh, I guess I don't have the clear image right now. I'm in the research about that. So I just googled different data structures which are disk related, which can be used for that. I mean, as design, of course, it's supposed to be map in some terms because we were supposed to have the PC index map uh, into the piece itself. And we also talked with Nazar about the different map from the from the tag to the piece index, right? So yeah, I think I'll spend some time for research on the some of the data structures with design like that. So hope I will have some progress in terms of that soon.
I think you can just use RocksDB that you already have. It explicitly has ability to do like range searches for keys. So you should be able to start from like one side and go to the center. This is how we actually find solutions for the target. So I think the same approach can be used for the this hash or like this index hash.
Okay. Okay. Yeah.
Read the documentation that they have, like how they put data and like what kind of queries you can make. I think it will be okay.
Sure. Yeah. We'll do that after the call. Thanks a lot.
Which data structure are we going to change?
Data layout for the plot, because right now we have an assumption of having all of the pieces in the plot on the disk. So it needs to be changed for the partial replica, as we will have only some range of the pieces which are close to our identity, and it will.
Okay, I think there was some confusion. I don't think we need to change the plot because that's the biggest thing, and we don't really want to make it less efficient. So the plot itself will remain the same. It will be just a bunch of pieces contiguously written one after another. You just need additional mapping. So when we want to replace a piece, we need to find which piece to replace.
Okay, yeah. Yeah, makes sense right now. Yeah. Okay. Thanks a lot.
Yeah, because right now it's just stored by offset, right? Because we know we're storing everything.
Yeah.
So we just, there is no mapping. It's just memorized in the data structure itself. So we just need
It's just implicit. We need to make it explicit so we can like manipulate it later.
Yeah. So I think a simple hash map should be sufficient. Just, index, piece index to offset on disk. It doesn't need to be anything complicated. I don't think there's any special data structure that provides some optimization on that.
Well, it will be piece index hash, because we need to quickly find what is closest to your node ID.
Okay, but when you look it up, you want to do it by piece index because that's the way it's going to be requested over the network, right?
Right.
Okay.
So we'll probably have like 2 additional mappings. One is like from index to offset, and another one from the index hash to whatever.
I guess you could just request it by hash over the network. Like you could just assume that it's hashed as part of the lookup algorithm, and that would then you would need 2 data structures.
Yeah, actually, yeah.
Okay, so yeah, so it's just a hash map, right? It's just piece index hash to offset. Should be fairly straightforward.
That one, plus we also need to modify the tags, because right now we are pointing to offset. We probably want to extend it to point to offset plus piece index, so we don't have to like go backwards from offset to piece index. But that's like debatable. You can potentially write it on disk right next to the data itself. There is some flexibility there. Probably need to do some like testing. Whatever approach takes less space, to write like index 8 bytes and the piece 4 kilobytes, or putting that 8 bytes into the mapping of the tags. I think either way will work. The first one will probably take less space.
Okay, I'll try to look for that. Thanks out.
So right now we store it by offset in the.
Right now we are storing it like offset and piece index is the same. So we are calling it piece index in every place. But we'll need to like separate those concepts.
Okay, well, if we already have a map, a database of the piece index to offset or piece index hash to offset, can we just store the piece index hash and do two calls?
I'm not following.
Well, we're saying what we were talking about just a moment ago. We have a map of piece index hash to offset, which is how we retrieve them from the network. And so if we just store the piece index hash in the actual RocksDB binary search tree as for the tags database.
It doesn't help us because we need sometimes to retrieve pieces just because there was a request from the network. It's not related to the solution. So we need to have a way to find it. Also, we need to be able to, like when we have a new piece, we need to identify which piece we need to replace with a new piece. And we need to be able to do it quickly. It's like we need to find the furthest piece from your node ID and replace it with the new one, like replotting. And that process should be efficient.
Yeah, Srivatsan actually devised an efficient algorithm for that over the summer. It should be in the documentation on the decentralized storage. Because that was actually a challenge of how do you update.
Okay, I remember something like that.
Multi-replica plots and condense it down into one plot over time, and there's actually an efficient algorithm for that.
Okay, I remember that we've discussed that, but I haven't actually read it ever. Is it still in Notion?
I hope so.
Farmer protocol, centralized storage.
I know we talked about it.
Yeah, we definitely did. Cost of storage, other questions, durability, farming pool design? No. No, I don't know where it is.
So what's the strategy right now, or that we're going to implement for how to do the updates?
Update to the plot, right?
Yeah, like if we have like if we're doing multi-replica farming and we have two node identities and we have two plots of equal size, and then
we're not discussing two plots yet. We're just discussing one plot and limiting it in size.
Yeah.
Oh, okay. So we're not doing efficient updates for condensed plots yet.
No, we didn't discuss it yet.
Okay, so then what is the efficiency? So we're just trying to determine how to evict pieces to add new ones right now.
Right.
For a single replica.
Yeah.
Okay, so this is just partial replica farming right now, not multi-replica farming.
Yes, exactly.
Okay. Okay, so what's the strategy right now for doing that eviction policy?
The first thing which I thought about was using the binary search tree and just looking at the borders of that. So maybe even storing the storing the borders of the range and just replacing it after we need to have.
Just like caching the edges, basically.
Yeah.
That makes sense.
But that cache will become out of date as soon as you replace one piece, so you will need to retrieve it anyway.
Every time you evict a piece, you just update the cache. It shouldn't be that frequent, right?
I mean,
we could have a small cache. Sorry, go ahead.
Yeah, we don't have to like write it on disk anyway. I mean, we can just read everything like at the start of the node. So and just cache it on the start of the range itself. So we don't have to update it every time we need to replace a piece.
Could we write the plot in distance order so that we could just read the edge of the plot to replace a piece?
I don't think so. As like if you have like full replica, it needs to like we need to insert a new piece, and it can be random, right? So at the random place, so it can be inserted in the middle, and we need to basically move like half of the plot. So this seems not an option.
I don't mean writing it in the order that it appears in the history, but writing it in the order it appears as distance from your node ID.
That's what we are saying. Like you'll need to move a lot of data in order to like sort it on disk.
Yeah.
Like you will receive pieces in random order from the network. There will be like new segments will be produced
in the writing process itself, not the update process.
Well,
I mean, if we're supposed to have a full node, we're receiving like a new piece, and like hash of the index, it can be random, and it can be either like close, or it can be to your node ID, or it can be like very far away from the node ID. So, and if it's close to you, you need
We're talking about initial plotting. It's difficult to write it in that order in initial plotting, is what you're saying.
It's actually easier in initial plotting, like assuming that you can request it from others.
Okay.
So you can like request it as a range potentially. But if you want to update it, you'll end up inserting in random places. So basically, I don't think it's an option to write it in a sorted way from the beginning. It's easier to maintain the mapping with something like RocksDB. It's already heavily optimized, and it will be like a small additional database.
I mean, just a thought which came to my mind. I mean, we know in advance the piece index, right? So I mean, it's still possible to do it this way. I mean, to have everything sorted. We just need to like move the data like in advance also, because we know VP syntaxes in advance, but it's not. Yeah,
we kind of know, but not really. So the way piece index will be organized, as far as my understanding so far is, there will be two parts to the index actually. So it will be not like 0 to 2 to the power 64 minus 1. It will rather be like 64-bit of the piece index will actually be separated in two parts. 48 bits will be the like number of the piece in a particular shard, and the other 16 bits will be just a shard index. So that will like compose number. So while you can't like grind on it and figure out which hashes you will get, that will be like compute expensive, and generally you'll have like insane numbers, like 2 to the power of 64 variations of what is potentially plotted, which is not something you want to like compute at all.
Yeah, true. I mean, we can just lazily compute for the like next 10 pieces. So yeah.
Potentially.
Yeah, but it's still like too much data wrangling on the disk.
I think we need to have like simpler version with RocksDB first, and then we can optimize it later. It will not break the protocol. Just need to work properly first.
Mm-hmm. Sure, yeah.
Do we have any kind of specification document or implementation plan that you're working off of right now, Ivan?
Not yet, yeah. I can write it all, actually. Should I put it on the farmer domain on the Notion?
It should be in Notion with the existing spec that we have, the decentralized storage under the farmer protocol.
Mm-hmm. Okay. Mm-hmm.
I think it might be valuable for us to agree on that spec before spending any effort writing code on this, because it seems like there's still some open questions and maybe some stuff that's left up to implementation imagination right now.
Mm-hmm.
But there could be some rework if we're not clear on this. How do you feel about that, Nazar?
I don't really see any questions from the design point of view. It's just like implementation details. So I don't know. I'm not so sure how necessary it is.
I mean, at least we can document it, the decision itself, which we came to like during this call.
Sure. Let's do it.
Okay.
Any
Okay,
other questions, comments to what one was working on?
Yeah, so the first step is to make it so that we can efficiently update the plot, to change the data structure so that we can incrementally update the plot. And then what are the next steps after that, Ivan?
The next step after that will be update the replacement policy. I mean, just update the API in order to have the replacement policy for everything. And I think the second PR like will be in terms of the integration mostly, because I think there will be many issues related to the because of the API change, everything can break inside of the farmer because of the assumption of having the full replica. So yeah, I think there will be many discussions there because I can't predict everything right now because I don't have full vision of the code base still. So yeah, the second PR will be the second step will be just integration of the partial replica and replacing the old pieces with the new ones.
Okay, but we're going to make it, I think the intention is that even though the implementation supports partial replica farming, the settings are going to be such that it will still be full replica until the blockchain
Nothing will
size.
change with the first step. It will be just documentation and like extended on the API to support it.
Right.
Yeah.
Okay.
Yeah. I also think from the CLI point of view, we can have just an optional flag for supplying size, and maybe like we can know also the size, full size in advance. yeah, but it can
There will be
also change.
some tricks around that in terms of user experience later, but we'll get to it.
Yeah, sure.
Okay, thanks. That's all the questions I had.
Okay, thanks, Ivan. Ozgun, did you have anything to share from last week?
No, you submitted a PR this weekend. I tried to review it and try to contribute a little, but no significant changes from my side to the core protocol.
Any other protocol problems with node integration in the Subspace desktop?
No, a small note though. I previously talked with you that slot API duration not found. Do you remember that error?
Slot?
Slot
No.
duration API was not found.
Well, that was, I think, with incorrect version of the node and runtime and something like that, but that's irrelevant.
Exactly. During the trials, they were just for test cases. I discovered something weird, at least weird for me. For the execution strategy, in the field other, when it is not native else WASM, sorry, it was always WASM, and I changed it to native else WASM, and this error disappeared.
Well, because you ignored the runtime.
Yeah. Yeah. Okay.
Well, I think it's irrelevant. We shouldn't
Yeah,
need to use it, and the native runtime is going away anyway. So
yeah.
the option will be gone soon.
Yeah. So to answer your question, no problem on the node integration side. We are just waiting for the release.
Okay. Can we already merge whatever we have into the master branch?
No,
because for me, the master branch doesn't even compile on the desktop farmer because it doesn't have like the correct version of nightly pinned and everything. Like it just doesn't build at all. So I'm wondering, like, what are we waiting for if it already works?
Okay, it's working, but don't we need the actual new test net to test the farmer?
But you don't have to make a release. It can be just in the master branch, and later we can update to the release.
Oh, sure. Yeah, we can do that.
I just feel like we don't like have any visible progress there. Would be nice to like get it merged and move from there.
Okay. Yeah, we will do that. It's ready for PR and merging.
Okay, cool.
So we were able to get code signing working for the Mac binary? No.
I spent so much time on it. Basically, yes. The code signing on Mac works. They basically have like 3 steps. The first, you sign the binary. Second, you package into the archive and send to Apple to actually notarize.
Yeah.
And then Apple knows that this thing was signed, and this is how it was signed. So next time when you open it on your Mac will hash the binary, send the hash to the Apple servers, and you'll ask whether this thing is signed properly. And if the response is yes, it will allow you to run the application without any warnings. So there is actually a 3rd step to it, which is optional to, I think it's called staple, the thing, which basically embeds this proof from Apple into the binary, such that you don't have to have internet access to run it. This is like an optional thing. I added it to the CI, and it actually failed because the process of like checking on the Apple side is asynchronous. So you need to like poll it periodically to wait until it actually notarizes it. It doesn't happen immediately. So probably just remove that step. We expect people to run it with the internet connection anyway. That was like the only last error that I had. Everything else finally works. However, we don't have code signing on Windows side because apparently we have the wrong password. I tried all the passwords in the vault. None of them work. So still waiting for a response from Justin where those correct passwords are. And the action is weird because it actually fails to sign for Windows, but it still doesn't error. So everything looks fine, but if you go to logs, it's actually not signed. So that is something we need to figure out. But they did figure out like what were the problems, why it was hanging, and everything. So I think we are almost there.
Okay, so
sorry, John.
Go ahead.
Okay. So we tried with Justin yesterday on my machine, just signing the node part, and it worked. And we had to get a response from Apple it was sent to Justin's email, but we didn't try on Farmer, and the error we got from the CI was related to Farmer executable. Could it be the reason?
There is no error. It's just about stepping.
Okay.
It's just asynchronous. You need to wait for like email on your like inbox, or you need to pull it.
Yeah, I know.
check.
Like, if we had done for the Farmer with Justin, maybe it wouldn't be the issue. That's what I'm asking.
Well, in CI, it actually signed both and it notarized both without any problems.
Okay.
So everything's good there.
Okay.
Okay, so we just need to get the password from Justin so that we can do the Windows code signing. We're going to disable this final step for Mac, and then we'll be ready to release and then update the Farmer off that release.
Yeah.
The desktop. Okay. Yeah, I don't think we need the final step, because if you haven't, if you're downloading the binary, you already have an internet connection. So it seems.
Yeah, there are like edge cases if you're like offline and you want to test locally, but like we can forget about it.
I mean, you can't even run the Farmer if you're offline, right? So it doesn't.
You can, like, you can run local node and you can farm locally, but it's not very
okay, but that's not very practical.
Yeah.
Okay.
Okay, Lu Cheng, what you've been working on?
Sorry, I had another question for Özkan, or I guess for both of y'all. Are there any updates on the GPU plotting with Supernational, the CUDA plotting, or sorry, the OpenCL plotting?
No. I actually have two laptops right now. One is with AMD GPU, one with Intel GPU, so I'll probably play with it on both.
Okay. Okay, so we just need to continue to test that ourselves and debug it. But from that point of view, they're completely done.
Yeah, I think so. I think we just need to have a list of instructions that are actually working, like step by step what you need to install to actually get it running. I believe they were using proprietary drivers for AMD, and for Intel, I think they were testing it on Windows, but I'm not sure. So we just need to play some more with it, but it should work. It should already work.
Okay. I think, Özkan, your priority is going to shift once we have a release of the desktop Farmer. I mean, there's going to be certainly bug fixes and whatnot coming down the line, but your priority is going to shift to actually getting this working with the plotting, GPU plotting on CUDA and
Okay.
AMD and NVIDIA GPUs working
Yeah, sure.
in the CLI and the desktop app.
Of course.
Okay. Sorry, Özkan, are there any other features you're actually working on the desktop Farmer, or is it just a matter of getting it deployed right now and published?
I'm planning to work on one more issue, like we are allowing multiple instances of the desktop app at the moment, and we should not. So if you try to open a second or third instance, it should create an error that you already have an instance. So I was planning to work on.
It should just open the existing instance. This is what most apps do.
Yeah, okay, but yeah, we are not currently doing that. So implementing that could be the next step. Or I can shift to GPU right away if you want.
So if you double click the app a second time, you get a second window.
Currently, I believe so, yeah.
Oh yeah, that should just reopen the same one. So yeah, that's a pretty obvious thing. We should definitely fix that. Like Nazar said, it shouldn't throw an error. It should just do nothing basically, or just maximize the existing window.
True.
Okay, great.
Lu.
Okay, sure. Firstly, I share a Notion link, and okay, sorry. Let me share my screen. So last week, no solid progress on the decoupling execution because a few issues pop up. Yeah. So the last week, what I has done is like I work on a separate branch where I trying to like verify the execution proof on the secondary node, because the fraud proof verification on the primary node is a variant of the verification on the secondary node, because there are some distinctions between these two environments. Like the primary node will have to like fetch the runtime code from somewhere, but essentially they will both depend on the low level functions, the execution proof verify. So I have make a list for all those problems. Most of them are implementation details. This one, the signal runtime. Okay. This one, the signal runtime integration on the primary chain is more of a design question. So maybe we should start with this one. How will the primary node to get the runtime code of the secondary chain?
Hey, Li Cheng, sorry, I just trying to make sure I understand the big picture here.
Yeah.
So you're saying since we don't have an integration of the runtime, the secondary chain runtime right now on the primary chain, what you're doing as an initial way to test this workflow is to generate, have one secondary node generate an invalid execution receipt, another secondary node generate a fraud proof for that, and then verify that fraud proof on a secondary node.
Actually, I haven't come to that point to verify the proof on the primary node. What I am trying right now is to make sure the execution proof verification function works correctly. The easiest way to verify this is to verify this function on the primary node that is already available.
Wait, but it's not on the primary node because you don't have the runtime. It's already on the second node.
Okay, so that is what I meant. There are some distinctions between the secondary node and the primary node. Like the primary node needs to fetch the runtime code. They fetch the secondary runtime code from somewhere. That's the distinctions. But otherwise, the other things is basically the same. We need to ensure all the other things, the low level, like APIs functions, works as expected, right?
Okay, so you can't verify on the secondary node, or you just want to skip that and go straight to the primary node?
Actually, I have done this one, the verification on the primary node. Let me show you.
On the primary node?
On the secondary node.
Okay.
On the secondary node. Okay, so maybe I can walk you through these commits. So firstly, I changed this substrate dependency to my own fork, because this one had not been merged, and today I received the first batch of feedbacks. Okay. I'm still discussing with them.
Is it positive? At least, does it look like it's moving in the right direction?
I don't think they have fully understanding of our case. I have to like explain this like again, like this. So
You didn't explain to this one yet.
okay, yeah. So and this one, okay, this one is something like we create this like execution proof, which is the core of the fraud proof, right? This one is already like supported in Substrate natively. What I need is this like exposed overlay API that I have like proposed in this PR. It's not merged yet right now, so I have to work on a separate branch. Okay, so I create this like execution proof for this extrinsic at this like index, right? And later I
Sorry,
implement.
why does it need to be? What's the extrinsic index?
Okay, the like a block has multiple extrinsic, right? Like the each extrinsic has an index in that block, right?
Right.
So we so whenever we find like invalid like a state transition for the index, like we just like need to generate a fraud proof for.
Oh, I'm
that.
sorry. This is for the fraud proof. Okay, got it.
Yeah.
My
So
bad.
so
That makes
here
sense.
we create. So here we create the like execution proof for that extrinsic.
Okay, so execution proof is a fraud proof, or is part
It's
of a fraud
the
proof.
core. Which is the core of the fraud proof. We all also have to include some like other fields, like the pre-state root, post-state root, and then the
Right.
extrinsic itself.
Right. Makes sense.
Yeah, which is the core.
But shouldn't this function be called create fraud proof?
It's still a work in progress. I haven't like make it the final version, so just ignore that.
Okay.
Okay, so this one is to actually like start to fix this to actually generate a photo proof, something like this. It's still not a complete. Still a work in progress. Like we will some the pre-state root and like a post-state root, and then this proof is what we like implemented in the last commit, the core of this proof. Okay. And then, okay, this one is okay. It's an implementation detail. We needed to like fetch the extrinsics, like to form a complete block builder to rerun like the extrinsics between the like the fraudulent like extrinsic. Okay, here comes the test for the verification on the primary node. Okay, fourthly, I need to like expose this backend for some other testings. The one is like as this like state mismatch test case, I start spin up like a primary node and then the secondary node, and then like I compose a transport extrinsic. Like I construct this block builder right? I then create the extrinsic like execution proof for the first extrinsic, right? Like once I have this like storage proof, which is the core, I like then add this pre-state root. Okay. Okay. Not this one. Should be included in this commit. Okay, this one. So we in this commit, I just like extended the existing serious test framework, like to expose this backend and some other things for the later usage. Okay. Here like I have created this like extrinsic proof for the first extrinsic, right here. In the next commit, I will like to construct a new block builder, which is to we pretend we are another like secondary node, okay, and we like we construct a new block builder like with this like extrinsic, and we verify this proof produced like by another like block builder. So actually, this verify like is successful only with okay. So okay, this is the first issue I mentioned in the notion. Let me browse the files. Actually, this verify like execution proof is similar to this like create execution proof. This one is already available in the substrate. This API is like my modifications to the substrate. It's not like exposed yet, so it has to be done on my substrate fork. Okay, this one to verify this extrinsic like execution proof, we need the initial state to executing this extrinsic, right? And this initial state is actually the parent block state plus this like overlaid changes, which is the change size accumulated like since the zero like extrinsic until this like target or the fraudulent extrinsic, right? So that is kind of the problems. Currently, this execution like proof generated by this doesn't include the change size in the overlaid changes. So we need to some way to convert to also merge these like overlaid changes into this execution proof so that we can like verify this proof without this overlay, because we can't.
It feels like you need to create a new overlay, which is like an overlay on top of overlay, so you can like capture all of the requests to storage. Then you should be able to like capture all the things necessary. Because it's like it already read some things right up to this point. It may already have some stuff. It will not like record them anymore.
This overlay changes doesn't include the parent block state. So
right, but if this is like second extrinsic, it will already contain some keys that were read for the first extrinsic, right?
Yes. Yes.
But we need to include that in the proof.
Okay, I got you. So when you like generate the execution proof for some extrinsic, right? This past overlaid changes, the storage like the stored values like recorded in the overlaid changes is not like recorded in this proof.
Yeah.
So when you verify this proof, if you doesn't have this like overlaid changes, this verification fails because you will miss some storage key.
Right, that's what I'm saying. Like we need to create another overlay, like a custom one, which can intercept all of the reads during this particular extrinsic, so you can like add it to the storage proof.
Okay.
So later you will have everything necessary right away without any overlay.
I don't think they will accept this kind of PR to have a custom overlay.
Well, have a parameter which is like option of overlay. If it's not provided, it will use like a built-in property, like self API overlay, whatever. Otherwise, it will use the provided one.
Yeah, maybe, but there is also some other ways. Maybe like change these overlays, like changes to another storage proof and then merge those two proofs. Like this one is a proof, like right. This one also convert to a proof.
That's what I'm worried about. Like imagine that you had like 10 extrinsics and then you want a proof for the 11th. And those 10 extrinsics read a bunch of state. You really don't want to include state in the proof that will not be used by that 11th extrinsic. It will be just like extra space. So you really like want to isolate what that particular extrinsic needs and nothing more. And for that, you need to like intercept what it was like trying to do.
Okay,
and record everything.
Okay. You mean this overlaid like changes is actually a superset of this?
Exactly.
Like,
yeah.
Okay. Makes sense. Yeah. Yeah. This way could work. Yeah. So this is the first problem.
Sorry, I've got a question on that, Lucian. I'm just trying to follow what's going on here.
Okay. Yeah.
So when we're doing the verification, whether it's on a primary node or a secondary node, anybody who's verifying this fraud proof or executing the fraud proof to see if it's true or false, it should not require any notion of an overlay. It should just have some inputs.
Yes.
Right?
Yes.
Yeah.
Right.
But we need an overlay.
Yes.
Eventually, yeah. But we need an overlay. I mean, Substrate has overlays, and we have to interact with these overlays in order to generate the fraud proof, the storage proofs for the particular keys that we need in the fraud proof generation. So that's kind of the issue we have here: is how do we read?
Yeah, it's both read and write cache. And if something was already read, then it will not capture in the proof that was generated. But we do need it.
Yeah. But the verifier really should not have any notion of an overlay.
Exactly.
It's not.
Yes.
Yeah.
Yes.
Okay.
Eventually, we will have like this only one, like storage proof, the pre-state, the post-state, the extrinsic itself, and also the runtime code. Like you have to fetch the runtime code from somewhere. Yeah.
Right.
Yeah.
Okay. Great. So you're clear on that now, Li Chang, on how to move forward? on this?
Yeah.
Let's like forget about the primary chain for now. Let's just make sure that like primary chain, if it receives the fraud proof, yes, fraud proof is correct. Let's punish them. Just let's make sure that the secondary node can verify everything first.
Yes, that is like my initial idea.
Yeah. Okay. What was the next question, Li Chang?
So the next question is actually like currently this execution proof doesn't return the post state root in Substrate. It returns the execution results. It doesn't like return this post state root, which is necessary for our use case. So
post state root is after last extrinsic, but before running all the hooks at the end, right? Is that what you mean?
Yes. Yeah. Yes.
I mean, in between
For the-
extrinsic start of the next one is the end of the previous one, but for the very last one, it's not the case.
So could you state that again?
Okay, so during block execution, you have like different phases. You have like preparation before the very first extrinsic, where there are like some initialization hooks and everything. Then you have extrinsics one by one, and then you have some finalization hooks.
Okay, got you. It's not that kind of problem, but actually, we for this like extrinsic like execution proof, we are only talking about this like apply extrinsic like method, which the initialize block, the hooks are unrelated. They are not related to this like extrinsic execution proof. So
sure, but what is post state root then?
Okay, let me show you the example. Maybe it could be clear. Okay, so currently, like you run this like execution proof, like a verification. You verify this like a proof.
So it's a state root storage proof overlay in the runtime call. Okay.
This one, it's the execution result. So it doesn't have the post state root. So we need that.
Wait. What kind of result? What are those bytes?
This method so the WASM has a method, right? It exposes like a batch of methods you can call from the WASM, right?
Yeah.
Like the block builder, like the apply a block builder, apply like extrinsic, right? Which is the method, and the core data is the encoded extrinsic, right? When you you run this method with given core data, it has a like a return value for this function. Block builder apply extrinsic.
So it's like a result or something?
Yes. It's a result of this method. So the post state root is not there. Okay.
Okay, but if you are talking about the proof check, shouldn't it return like true or false?
No, it doesn't return true or false. Currently, it just return the execution result in the like in here. I explained why it's enough for Polkadot. Like in Polkadot, they run this. They kind of have this execution result, which is actually the header. The header includes the state root already. So you just need this execution result.
Can't you call like a method and generate a state root at this point?
I tried to generate this story root after executed this method, but the method between running this running this call and after running this call, the story root is the same. So it's super weird to me. I haven't
well, but it's a
why.
check, so it makes sense. It's like not apply. It's just like check.
But inside this check, so I haven't really digged into this problem. I hope someone in Parity will answer this. So.
Okay, I'll have to dig into it. I saw this, but I didn't read into it yet. It would make sense for me that if it was returning a boolean, like this fraud proof is correct or not correct. I don't get why it needs to return like a vector.
This vector is just this execution result for this method, right?
I understand, but we don't care about the result. We care about whether it was executed correctly or not.
Yes. So we need to check it for our usage. But before that, I really hope someone, the Substrate folk, can answer this. Okay, this one is.
So this is another one that we're waiting on feedback from Parity on.
Yes.
That we're blocked on.
We can also work on our own one, but it's better to have an answer from there.
Okay. Yes. How long have we been waiting on an answer? Just 2 days now?
2 days.
Okay.
Okay. This third one is more of a design problem. So how to integrate the secondary runtime on the primary chain, how the primary node will get this secondary runtime code. Yeah, it's more of a design. Okay.
So the assumption in the protocol is that whatever runtime, WASM runtime, whatever just abstract runtime that executors have access to, farmers have access to that as well, the full runtime code. In the sense that they're smart contracts, then there would need to be, they're not expected to have all of the contract code, but that contract code should sit in a state database, which you can prove as part of some contract as well. So that's a later thing. I'm just trying to make that distinction clear. We don't need to worry about smart contracts, but right now, just runtime itself, they should have access, or the farmer should have basically this read-only access to this runtime, just to call this verification. So I don't know. I think
it is a little bit confusing way to think about it, because it's not that the farmer needs to access to the executor runtime. Its executor's runtime should be in the farmer runtime. So when farmer runtime upgrades, it also upgrades synchronously on the executor side, so it's derived from it.
Sure, absolutely, yeah. I mean, it's just the network's runtime. They both have access to it.
Yeah.
But the farmers are the ones that ultimately decide what that runtime is.
Yeah. So I was thinking, since all of these runtimes, they eventually build into WASM binary, we can probably include the secondary runtime just like another blob in the primary runtime, and make secondary runtime somehow like read it from there via like runtime API or something, and like track when the runtime upgrade happens to like follow
Okay,
it. From there.
okay, so we are like store this secondary runtime on the primary chain, right?
Basically, yes.
Okay. Okay. So when this, when the primary chain node or the primary chain network, like or the Fermat network, like starts, it will be in like a secondary runtime code in this Genesis. Okay, right?
Yeah. So basically, there will be like a WASM blob for the primary chain, and it will have like a constant, which is like a string or like vector or like the slice of bytes, and that slice of bytes will be the secondary runtime in it. So it will be in the chain spec.
How will you upgrade this secondary runtime?
So I was thinking that since it's a part of the primary runtime, you just need to update the upgrade to primary runtime. And secondary runtime should like see an extrinsic that like this runtime will be upgraded at block like n. So when block n happens, you need to like read the new runtime from the primary chain via like runtime API call or something.
So if it's in the primary chain stage, where like it was like was it stored? Where does it store?
So you have these runtime APIs that you can call. We can have like one runtime API method, which is just returns a vector of bytes or something.
I mean, runtime. Like where you put this like secondary runtime blob? In which palette? Oh, yeah.
Not in the palette, in the runtime.
Okay,
So if you go to the Subspace runtime, where is it?
Okay,
runtime.
Okay, I got you.
At the very top, you have this like include of the WASM binary.
Okay, I got you. Okay. So it's is it directly like a constant in the runtime?
I was thinking about that. Yeah.
Okay, whenever you like you want to upgrade this runtime, you have to like change your runtime module to update this constant and do the upgrade. Okay. That should work. Yeah. Okay.
Like this is not something that is currently supported. We'll probably have to like modify something because I think there is only one way to upgrade runtime right now in Substrate. This will be like a second way to do it, like pull it from somewhere external, but it should be doable.
Okay. Okay, we can have like a deeper discussion as we come to that point. So far, this way actually like at least it should work. Yeah. So the final one is like another implementation detail where this like execution proof is a STD only function, but we want to like verify this for the proof from the runtime, which is no STD environment. So we need an externality extension for that purpose to call the like STD function from the no STD environment. Yeah.
Yeah, I was thinking about that. I don't think POVs are verified in the runtime, right? It's not an extrinsic. So maybe we should also verify it like outside during block import instead of like in the runtime.
Yeah, but the Polkadot is kind of complicated. If we go that way, we have to go to learn what they have done. They are pretty complex in some sense.
Okay, so
It's
if I
one
understand
of
the
the way.
question,
Yeah.
the question right now is, do we do the fraud-proof verification in the client or the runtime? And in Polkadot, they do the POV block verification in the client. But right now, we're
Yes.
trying to do the fraud-proof verification in the runtime, but we can't because
Yeah.
it's no STD.
Well,
Yes.
runtime, when it runs against some like snapshot of the state, and you almost need like a snapshot a little bit later than the beginning of the block, or like the end of the block, like in the middle. And there is really no way to like move it to that like force it to that state just with the runtime. You can like do something from the outside, like to inject that information.
How do we verify equivocation proofs? Is that inside the runtime or outside?
Yes, it's easier. It's just 2 headers. So we created an extrinsic which has 2 headers in it right away.
Mm-hmm. But we don't need access to the state to verify the fraud proof.
But you have to spin up like a virtual machine to run like the executor.
Okay, but if you run that virtual machine within runtime, like nested.
Yeah, like definitely like palette contracts, but
Yes, something like
that is like another way, also complicated in my opinion. We can
like runtime within runtime.
We can make the final decision when we come to that point. Before that, we have to tackle those 2 problems.
Okay, but it will be interesting problem.
Yeah.
I mean, I think the preferred method would be just to verify it in the runtime without a secondary runtime, or without having to spin up another virtual runtime within the runtime. Which we can.
Well, first of all, it's like an exception. It's not something that will happen often or if ever. This fraud proof. So it's not like it's a big problem. But I have another concern about this.
If we make changes to it, then it will be a hard fork. We can't change it through runtime upgrades. We change the fraud-proof verification mechanism.
You mean if you move it to the client?
Yeah.
Well, kind of. We can still have versions. I think, like, I don't like this whole thing in general. For instance, we still don't have an answer what to do if the particular call has read a lot of data. Like it can read, let's say, 10 megabytes, and we have a limit on transactions, something like 3.75 megabytes. So we physically cannot put the fraud proof into transaction. Just not possible. How do we do in that case? Do we like force the block size to be bigger just because we need to? But then what will be the propagation delay? Like,
but that doesn't matter if it's in the client or the runtime. That's just a problem with the scheme. It has to be a transaction no matter what. We can't have it be outside the context of the chain.
Kind of.
I mean, the idea is that it should be like an equivocation proof where the fraud proof itself is just a network message, and then the node that verifies the fraud proof, all nodes verify the fraud proof, and then if whichever farmer farms the next block includes the fraud proof as the special transaction in the next block, just like equivocation proofs are. So it's going to have to be put on
yes.
chain.
However, like theoretically, yeah, it could have been the other way around. We could have had just like a commitment to it on the chain that this like thing was incorrect, and we can send the data for the fraud proof like POV out of band, kind of like bundles. We have headers, we have the full bundle. So we like include the header of the fraud proof on chain, and we have the full fraud proof in the run, like in the client. We verify it, we like make sure it's correct, and then we commit it on chain. So everyone who is following the chain right now will have it. If you come later, you'll have to generate like this extra data yourself. So you can like run the executor, you can extract information from the storage and make sure that that fraud proof was correct, but those inputs, they are kind of like redundant. As soon as you have execution trace, you know where it was wrong, and you can later confirm whether it was wrong or not. But you don't necessarily need to include like all of the state reads and writes on chain in that case. And then you don't have this problem where we need to like include a lot of data on chain in the transaction itself.
There's a data availability problem with that, though.
Of course, of course.
Is that, I mean, is that really a reason to not? I don't know. Yeah, I feel like we're gonna have to have a limit. Like, I agree, we need limits on the fraud proof size, and there's got to be some way to enforce that within the protocol with respect to all the.
So it's not on the fraud proof size; is on the like transaction reads, basically, like a gas, but for like how much stuff you can read and write. Mostly read during transaction execution, so it doesn't exceed like the fraud proof size.
But the reads, I mean, reads from the state database, you mean?
Yes.
For the fraud proof verification?
How we need to have a limit on how much data the transaction execution, like transaction call, can read from state database, such that if you were to generate a fraud proof of this transaction, it didn't exceed the side limit. So you can like
on the
only
executors,
operate on it.
You mean on the fraud proof
Yes.
generation side, not on the fraud proof verification side?
On transaction execution side, before any fraud proof, like we need to limit how much transaction can read.
Right, but what is your concern with if the reads are too high? Is it on the generation or the verification side?
Then the fraud proof generation will produce a fraud proof that is bigger than transaction limit. Will not be able to physically include it on the primary chain.
Basically, limiting witnesses, right? Of the transaction.
Well,
it's called storage proof in that case.
Yeah, it's a witness.
Oh.
It's just a Merkle proof at the end of the day, a storage proof. Yeah, I mean, I think that's reasonable, but that's doable. We just need to say, I mean, those witnesses only increase in size logarithmically, so we can have.
It's
like
not just witnesses. We need to include the data itself.
Right.
So actually, I have like another hacky way. It's a way hijack the transaction pool. Which is a totally like STD environment. So there's no like limits there.
So you want to make the
This
block bigger than it should be on the primary chain, like allow it to include the transaction?
So when you like submit the fraud proof extrinsic, it firstly goes into the transaction pool, right? So we verify this fraud proof if it's like correct or incorrect in the transaction pool, and only one the like successfully validated like fraud proof will be submitted to the runtime.
Right, but we still have like the limit on the transaction size. We have a limit on the block size. If fraud proof is too big, then it just doesn't fit.
Yeah.
Like we need to expand the block as a special case or something.
Yeah, at least we don't have the read limits. We don't have the read limits, at least. Okay, right? But you're right. We still have the limits on the transaction pool itself.
Well, transaction pool is much bigger. Like it's, I think it's 10 megabytes or something by default. We can expand it to whatever size we want. It's more like a block size limit that I care about. Like we can put it in the like inheritance.
No, I mean like we don't include the whole fraud proof on the chain. We include the validated fraud proof.
That's what I was saying, and Jeremiah didn't like it.
Okay.
Like I suggest to include like a header and everything verified in the client.
Okay.
Then we have this data availability problem. When someone will receive a block, and they see, aha, there is a fraud-proof header in this block, but where is the body? How do I get it? Does it even exist? You know, and that's like not a trivial problem.
Okay. Okay. So this week I'll try to tackle the relatively easy problems. Maybe. Okay.
Okay. Is this all for now?
Yes. All my updates.
Okay, I'll try to look into that discussion on Substrate and the pull request. I'm already subscribed. I didn't read the messages yet. Okay. On my side, there was just one fix. I guess I can share it with you guys. You should see this. So we had several problems, and there was one even duplicate of this. Basically, the experience was that when you start a node and then you start the farmer right away, the farmer, like the node will start the sync process, right? It will try to import blocks as soon as it can. But that also means that there will be no notifications about the new best block. It just doesn't fire in Substrate when it imports blocks because it happens so often. So the problem was that farmer was basically waiting for the sync process to finish, which can take like hours. It was doing nothing in the meantime. That was a problem for user experience. Many users tried to run a node last week, and they were basically a little bit confused that farmer didn't like solve anything, didn't do anything really for a long time. And we had to explain why. And there was this other problem, which is unrelated, but is also fixed by pull request, where at some point there is this like bug in the WebSocket connection that basically corrupts the connection itself. It's kind of open, but it doesn't really work anymore. Like you cannot send or read messages, like nothing is really happening, but it's still open. So from the point of view of node and the point of view of farmer, everything is fine, but neither can communicate with each other. And that basically stalls block production if you have just one farmer connected to one node, which we had several times on the testnet. So the solution to both of them is basically a rather hacky solution. There is this new RPC call, get best block number, just returns you a number every time you call it via RPC. And the farmer will just, where is it? This is some refactoring. Yeah, this is very hard to read. The farmer will basically, in the loop, every few seconds, it will try to get the new best block from the node, and it will try to update it. And that will basically be the same kind of mechanism as if you receive a notification from the node, but you will like proactively additionally request it from time to time. So even if sync process happens, this number will update. So like every few seconds, we will have some more blocks to work on. And we'll also have a timeout here. And if you don't receive a request or like there is an error, will basically stop the farmer, and if it has like a Docker container to like restart right after this, which basically means we avoid this this stall as well. So this is like a relatively hacky solution to both problems. This was like one fix. There was another duplicate from Ozgan, I think, here that it was waiting for sync process to finish, which is basically the same problem.
Yeah.
There was some refactoring, which is a preparation to the sync from the network on the node side. Just had to move a few things around. And I was spending way too much time on the code signing. It almost works. And I was also fixing some issues on the Subspace desktop, which was related to action from Tauri update, and there are some other things, and also helped a little bit with node integration, which works without any CLI interface right now. So not super excited on my side, but this is kind of important thing, and it took a lot of time. It's like it was getting stuck. We didn't really know why. Now I know why, but we didn't know before. And the experience was something like this. I think this is the one. No, this is not the one. The previous. No, this is again not the one. Let me show the older one. I think this one. Yeah. So the experience is something like this. You just wait for 5 hours and it does nothing. Like it just gets stuck on this line. You don't really know like it's doing something, it's just slow, or it doesn't do anything. Like it was really, really frustrating. A lot of time spent on like CI test, like 6 hours for one run. This is super annoying. But it basically works. So just a matter of one more run. Yeah, this week I hope to have something on the networking side, finally working on this thing. Yeah, any questions to me? Any of this? Or anything else? All right. Thanks everyone for being here. Thanks everyone on YouTube for watching, and we'll see you in one more week.